Hello dear students, welcome to Biochemistry by Revati. I am Revati and in today's class we will continue with the Henderson-Hasselbalch equation, its biological importance and few numerical problems. If you want to know the derivation part of the Henderson-Hasselbalch equation, I'll give a link in the description below. Please go and check out. Okay, now let's start. Before going into the actual topic, first let's recall what is actually a Henderson-Hasselbalch equation. pH is equal to pKa plus log into concentration of conjugate base by concentration of weak acid. So here what is pH? pH is a hydrogen ion concentration, right? It tells us acidity of the solution. And what is pKa? It is a acid dissociation constant. Means it tells us how strong or weak the acid is, right? And A minus, it is the concentration of conjugate base. And HA, the concentration of weak acid. And this equation tells us the pH of the buffer solution by the ratio of conjugate base to weak acid or ratio of base to acid. Now let's see how this equation is useful in biological systems. Now let's apply this Henderson-Hasselbalch equation in bicarbonate buffer system. Right? What is the equation? Here the carbon dioxide which is produced during metabolism reacts with water present in blood plasma to form what? Carbonic acid. Again this carbonic acid dissociates to H plus and bicarbonate ions, right? H2CO3 is carbonic acid. Now applying the Henderson-Hasselbalch equation into the bicarbonate buffer system. What is actually Henderson-Hasselbalch equation? pH is equal to pKa plus log to the concentration of conjugate base by concentration of weak acid, right? Now applying the equation in the bicarbonate buffer system, we will get pH is equal to pKa 6.1 plus log concentration of conjugate base bicarbonate ion by carbonic acid, right? So what is 6.1 here? It is the pKa of carbonic acid. And what is this? Bicarbonate? It is the base level. And the carbonic acid, it is the acid level, depends upon the carbon dioxide produced, right? Now, if carbon dioxide increases, like in lung problems, what will happen? If carbon dioxide increases, simultaneously carbonic acid also increases, because if carbon dioxide increase, it reacts with water to form carbonic acid, right? So here carbonic acid level also will increase. So here carbon dioxide increases, carbonic acid level also increases, which leads to the pH dropping. Means, so here pH drops. If pH drops means what will happen? Blood becomes acidic, right? If in the case of bicarbonate level increases, like in the case of metabolic conditions, what will happen? pH raises. If pH raises means what will happen? Blood becomes basic, right? So using this equation, doctors can easily measure the actual pH of the blood. So using this equation, doctors can measure the levels of carbon dioxide and bicarbonate levels, and they can calculate the pH of the blood. Now let's take an example, means clinical example, right? If a patient has carbon dioxide level as 1.2 millimole per liter, and which will be converted, carbon dioxide will be converted to carbonic acid only, right? Okay, so here carbon bicarbonate level as 24 milli equivalent per liter, right? So what is the Henderson-Hasselbalch equation? pH is equal to pKa plus log the concentration of conjugate base by concentration of weak acid, right? So substituting the values in this, we'll get what? pH is equal to pKa 6.1 plus log 24 by 1.2. So what is 6.1 here? pKa of carbonic acid. So pH is equal to 6.1 plus log 24 by, in order to remove decimal we have to multiply by 10, right? So what you'll get, pH is equal to 6.1 plus log 240 by 12. So log 240 by 12, if you simplify, how much you'll get? 20, right? So pH is equal to 6.1 plus log 20. Again log 20 value is approximately 1.3. So you'll get, by adding this, 6.1 plus 1.3 is equal to 7.4. So this is the normal pH of the blood. Finally, the Henderson-Hasselbalch equation helps us to understand and predict the pH changes in the buffer solution which are going inside the body, right? That's all for today's video. I hope you have understood the concept clearly. And if you have any doubts regarding the concept, please comment down your doubts. And if you found this video helpful, please like, share and subscribe to Biochemistry by Revati for more simple and clear explanations, right? Please do support me. In the next video, we will discuss an important topic, that is the concept of stereochemistry. So until then, keep learning and stay curious. See you in the next class.